Alright, here is our video about Lewis diagrams. To start though, we have to kind of revisit the whole electron dot diagram, and just remember, let me get a pen here, whoa, sorry. When you're drawing the Lewis dot diagrams, all you have to do is look at what group is the element in. If it's an S or a P block, then the number of valence electrons is equal to the group number. I'm sorry, if it's an S block, not a P block. If it is a P block, then you take the group number minus 10. So like group 13 has 3 valence electrons, 14 has 4, yada, yada, yada. And when you're drawing your dots, remember, you got to follow Hund's rule. Everybody gets 1 before anybody gets a second. So if you have less than 4 electrons, then they get evenly dispersed at basically, you can kind of consider it northeast, southwest. And then it's on the 5th element or electron that you start doubling up. And then it goes on from there. It doesn't matter if, you go like these guys did where it went opposites, here and then opposite, or if you just go around in a circle. No, it doesn't matter. I tend to, just for ease, go 1, 2, 3, 4, 5, 6, 7, 8, like that. So it doesn't really matter. You do what you like to do. So a Lewis structure is basically, it's an electron dot diagram for a compound instead of an element. Back here, we had the electron dot diagram for an individual element. Here is for a whole compound. The dots right here, they show unshared pairs of electrons. So these electrons right here only belong to this nitrogen. They do not belong in any way to the hydrogen. And then the dashes right here show paired electrons. So each dash represents 2 electrons. And so that means these 2 electrons right here are shared between the hydrogen and the nitrogen. And the way that this works, your hydrogen has 1 electron normally, your nitrogen has 5. And you can think of it as, okay, hydrogen and nitrogen are, they're sharing a $2 lottery ticket. And so to purchase that $2 lottery ticket, hydrogen put in $1 and nitrogen put in $1. And so they share their lottery ticket between them. But this lottery ticket that was $2, nitrogen bought by itself. And so this would be an unshared pair, and this is a shared pair. So how do you draw a Lewis structure? This slide, hugely important, quintessential part of chemistry. If you don't remember anything from this class, please remember how to draw a Lewis structure. Step 1, and follow all these steps. Don't skip a step ever. And we'll do an example. Let's do SF2 sounds good. Sulfur difluoride. First of all, you need to determine what type of atoms and how many atoms you have in a molecule. So I'm just going to look at this. I'm going to say, okay, I have 1 sulfur and I have 2 fluorines. Step 1 done. Step 2, write the electron dot notation for each atom, not each element, each atom. So sulfur and 2 fluorines. So each sulfur has 6 electrons. Each fluorine has 7. Okay, step 2, done. Step 3, basically, count the dots, because the number of dots that you drew in step 2 is equal to the total number of valence electrons for this particular compound. So we have 6 and 7 is 13, and another 7 is 20. So 20 electrons that we need to deal with. Step 4, arrange the atom so that the first element, in this case sulfur, is in the middle, and the other elements radiate off of it. So we have 2 fluorines that we need to bond to our sulfur, so we're going to put sulfur in the middle. And whenever you're radiating 2 elements, radiating means just like kind of put them as far away from each other as they can get. So as far away from each other as 2 things can get is a straight line. If we have a carbon present, which we don't have in this particular compound, but if we do have a carbon present, it automatically goes in the middle. Okay, next, connect, not shared electrons, that's not what I meant to put. Connect the elements with dashes. So we're going to connect here, we're going to connect here. Step 5, done. Step 6, subtract the shared electrons from total electrons. Remember, each line refers to 2 electrons. So that line is 2 electrons, this line is 2 electrons. So our total shared electrons that we have right now is 4. So we're going to subtract it from this 20. 20 is our total electrons, minus the 4 that we have sharing going on right now. So that means we have 16 electrons left. Where do we put those 16 electrons? Well, distribute them as unshared pairs. First on our outer elements, so that we follow the octet, and then we put whatever leftovers are on the center. So this fluorine right here has 2 electrons, so it needs 6 more. So now we can take that 6 off of this 16, which leaves us with 10. So now this fluorine has 2 electrons, it needs 6 more. So take another 6 off, which leaves us with 4. Well now, so our center element's all we have left, so these 4 electrons go on the center element. And electrons are always as pairs. You can have a really weird situation where it's not, but as far as y'all are concerned, electrons are always in pairs. It's just whether it's a shared pair or an unshared pair. So we're going to do one example problem. Yeah, wow, that slide had a lot of words. We're going to do one example problem. We're going to draw the Lewis structure for CH3Cl. So the first step is to identify your atoms. We got 1 carbon, we have 3 hydrogens, and we have 1 chlorine. So now we need to do step 2, draw the Lewis structure. So 1 carbon, 3 hydrogens. Oh, I probably should have spaced those out better. Yeah, let me fix that. Okay, 1 carbon, 3 hydrogens, and a chlorine. Carbon is in group 14, so it gets 4 dots, 4 electrons, 4 valence electrons. Each hydrogen gets 1, and then the chlorine is in group 17, so it gets 7. Okay, step 2 done. Step 3, count the dots. We have 4, 5, 6, 7, plus another 7 is 14, so 14 electrons that we need to deal with. Now we draw our elements with the first atom in the center, and if we have a carbon, it's always in the center, so there's a carbon. And then the other elements radiate off of it. It doesn't matter that one of them's different, just radiate off. Oh, that's supposed to be a Cl. That's a Cl, I promise. Now step 5, connect them. Okay, and then subtract your shared elements from your total. So we have 2, 4, 6, 8 electrons. We're supposed to have 14, so 14 minus 8 leaves 6 electrons that we need to put on outer elements. So now we look at our outer elements and figure out who needs more. So this hydrogen, and this hydrogen, hydrogens are only allowed to have 2. Well, a bond represents 2 electrons, so these hydrogens can't have any more. So we go to chlorine. This is 2. 8 minus 2 gives us 6. So there's our 6 electrons. Leaves us with no more. So carbon doesn't get any lone pairs, which works out just fine because each bond, again, represents 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Everybody satisfies the octet rule and we are happy. And that bell means that I am done. If y'all have any questions, feel free to come in for tutoring and ask.